Oh no, we're caught by the black hole's gravity. What are we gonna do? There's nothing we can do. Black holes are totally dark. Nothing can escape them. Despite their harrowing reminder not to get too close to a black hole, those two spacemen actually got something wrong. In fact, black holes actually emit radiation. This is called Hawking radiation. Now, in order to explain Hawking radiation, we need to build it up from the fundamental principles from which it was based upon. That is, quantum field theory. Now, what is quantum field theory? It may just seem like a fancy word for a theory. However, some of its postulates are really cool. In the empty vacuum of space, particles are constantly creating and destroying one another, popping in and out of existence. But David, doesn't this violate the law of conservation of energy? Energy cannot be created nor destroyed. Why, in fact, it does. However, since the particles annihilate in such a short amount of time, the Heisenberg uncertainty principle allows for them to exist for this short amount of time. These particles will keep popping in and out of existence all throughout space. However, what happens if we apply them to the event horizon of a black hole? We have a particle pair pop into existence at just the right spot on the event horizon. Then one of these particles will fall into the black hole while the other one escapes. How can this be, though? Shouldn't this violate the law of conservation of energy? Because, after all, we are creating energy and matter out of seemingly nothing. Well, it turns out that the escaping particle is actually getting its energy from the black hole. This means that every time the black hole emits one of these particles, it loses a tiny amount of energy to these particles. Since the black hole is losing a little bit of energy with each particle emitted, it therefore loses a little bit of mass because of Einstein's famous equation E=mc², which tells us that energy and matter are equivalent. This process of emitting particles happens all along the event horizon and is what Hawking radiation is.